Assalamualaikum and hi. We are going to present our proposal titled Water Quality Competition. We are from Section 3, Group 5. Our group members is number 1 is Muhammad Adib bin Muhammad Rizwan, Muhammad Arif Ajmal bin Azmin, Muhammad Haziq Fikri bin Luqman, Aizati Rushda binti Muhammad Zabidi, Nur Alia Izzati binti Mat Zaini, and lastly Muhammad Nur Akmal bin Mat Sairi. I'm going to explain about the introduction. What is Water Quality Index? Water Quality data is summarized for reporting to the public in consistent manner. It is calculated based on 6 parameters. Number 1 is biochemical oxygen demand, chemical oxygen demand, ammonia nitrogen, acidic and alkaline, which is pH, and dissolved oxygen, and lastly is total suspended solid. Water quality index is measure the scope, frequency and amplitude of water quality accidents, then combine the 3 measures into one score. This calculate procedure score between 1 to 100. The water quality index can be categorized in 5 categories. The first one is excellent category, which is water quality index range between 100 to 95, and then very good in range of 89 to 94. And then good category in value 80 to 88, and then the fair category, which is the water quality index value in 95 to 79 value, and then the lastly is poor quality index, which is value is from 0 to 44.
Assalamualaikum. My name is Muhammad Akmal bin Mat Sairi, CF201362. Sub-index. An environmental engineering laboratory perform a various experiment and tests to assess the quality of water. Through this test and experiment, environmental engineering laboratory help identify and mitigate environmental risks and promote sustainable practice. Next slide is National Water Quality Standard (NWQS). From this schedule, we can classify the classes for the test that we may conduct. The test that we choose for this testing is pH testing, TSS, COD, DOD, turbidity testing, and NBOT testing. So here are the schedule for the classification of water based on NWQS. I will tell in the next slide. DOE Water Quality Classification based on Water Quality Index parameter. So here are the classes that I told before. So class 1 is conservation of natural environment. Water supply 1, practically no treatment necessary. Fishery 1, very sensitive aquatic species. Class 2A, water supply 2, conventional treatment required. Fishery 2, sensitive aquatic species. Class 2B, recreational use with body contact. Class 3, water supply 3, intensive treatment required. Fishery 3, common of economic value and tolerant species, livestock drinking. Class 4, irrigation. And class 5, none of the above. For index range, water quality data were used to determine the water quality status either in clean, slightly polluted or polluted category. And to classify the river in class 1 is clean, class 2 and class 3 is slightly polluted, and the class 4 and 5th is polluted.
This is the methodology of our group. Our proposed location for the water sampling is at Tasik Kenyir or Kenyir Lake, which is an artificial Bing's Lake in Hulu Terengganu, Malaysia. It is tucked away in the Pantai Timur Range. The lake was formed in 1985 by Kenyir Dam, it is located on the upper stream of the Terengganu River. The nearby Sultan Mahmud Power Station receives water from the lake. It is the largest artificial lake in mainland Southeast Asia, with a surface area of 260,000 hectares. Kenyir Lake also supports a diverse range of freshwater fish and exotic wildlife. Next, this is our sampling procedure. So firstly, we need to use the appropriate bottles, and sampling tools must be ready and in excellent condition before collecting sample. The crew has to make sure the pond has enough water flow and the environmental variables such as the weather, time and date are being recorded when the sample is being taken. So firstly, we need to get the masking tape, PTFE bottle and glove. Next, put on glove and thoroughly clean the PTFE bottle 3 times with water from intended leg. Next, when sampling the water, operator must make sure their glove is not completely submerged. Next, fill the PTFE bottle with 100 ml of water. Next, apply masking tape to the bottle so it may be labeled. Lastly, indicate the time, date, climate and place where the water was taken.
Assalamualaikum warahmatullahi wabarakatuh. I will explain about methodology of BOD test and COD test. For BOD test, first we collect a representative water sample from the site interest. Then we prepare dilation water using distilled or deoxide water. After that, determine the initial dissolved oxygen DO concentration of the sample by taking measurement using a DO meter. Dilute the water with the prepared dilution water to achieve a BOD level that fall within the range of the BOD probe used. Then incubate the diluted sample at a temperature of 2 plus minus 1 degree Celsius for 5 days. Then determine the final DO concentration of the sample after the 5-day incubation period. After that, we calculate the BOD concentration of the sample using the following equation, which is BOD equal to initial DO minus final DO times with dilution factor. After that, we repeat this step with running blind sample to ensure the accuracy of the BOD measurement. For COD test, first we collect a representative sample of the water to be tested. Then we measure the volume of the sample and record it. After that, prepare the dichromate solution by dissolving a known weight of potassium dichromate in sulfuric acid and diluting it to a specific volume. We add a measured volume of a dichromate solution to the sample and mix thoroughly. Then incubate the sample for a specific time period for 2 hours in a water bed at a constant temperature of 150 degrees Celsius. Then we cool the sample to room temperature and add a reducing agent such as ferrous sulfate to reduce any remaining dichromate to a colorless form. Then titrate the remaining ferrous ion with a standard solution of a suitable oxidizing agent such as potassium permanganate to determine the amount of dichromate that was consumed during the oxidation of the organic matter in the sample. Finally, calculate the COD of the sample based on the volume of the sample and the amount of dichromate consumed.
Assalamualaikum, my name is Muhammad Aziz Fikri Badoman with method number AF 2000F43. So I'm going to tell the procedure of nitrogen oxygen demand and turbidity test. So first, the NBOD test. First, collect a representative active sludge sample from an aeration tank of the wastewater treatment plant. Bring the sample to the laboratory and allow it to acclimate to the laboratory temperature for at least 30 minutes. Prepare a series diluted sample with different concentration of ammonia chloride solution to create a range of substrate concentration. Add a known volume of each diluted sample to a 300 ml BOD bottle and adjust the dissolved oxygen concentration to 7 to 9 mg per liter. Incubate the BOD bottle in the room at temperature of 20 to 25 Celsius for 5 days. Measure the DO concentration of each sample using a DO meter at the beginning and the end of the incubation period. Calculate the NBOD value for each substrate concentration by subtracting the final DO concentration from the initial DO concentration and multiplying by the dilution factor. Plot the NBOD value against the substrate concentration to generate a nitrification curve. Lastly, determine the maximum nitrification rate and the half saturation constraint from the nitrification curve using appropriate mathematical models. Next, the turbidity test. First, remove the dust cover from the instrument and turn it on. Allow the instrument to warm up for at least 30 minutes. Examine and clean the sample cells to ensure they are free from fingerprints, smudge, clean dirt or scratch. Rinse the cell 3 times with the sample water to prevent contamination. Add about 25 ml of the test sample to the sample cell, then clean the exterior of the cell with a clean, lint-free cloth or tissue. Check a sample for air bubbles and eliminate them by tapping the bottom of the cell or using a vacuum pipe. Choose the widest range possible for the expected turbidity of a sample. If the sample anticipated turbidity is too low, try the next lower range until the measurement is made. If required, insert a cell riser to shorten the distance between the sample cell and the dye detector window. Standardize the equipment each time the measurement range is altered using a male or secondary standard with turbidity that is 90% of the measurement range upper limit. Insert the sample cells in the instrument compartment and cover it with a light shield. Rate the turbidity of the sample from the corresponding scale using meter needles reflection in the mirror strip. Remove the sample cells and close the sample compartment door to preserve the instrument working order. Lastly, use the normality equation to make solution of lower turbidity value using distilled water for dilution purpose.
Hi, Assalamualaikum. My name is Muhammad Ibn Muhammad Rizal Harul. My metric number is AF200089. Today I will present about methodology total suspended solid. Okay, firstly, we need to dry filter paper for 50 minutes in the oven. Then we take out the filter paper from the oven and cool the filter paper in desiccator. Third, take out the filter paper from the desiccator. We need to label it, the evaporating dish, and weigh accordingly. For the fifth, place the filter on the base and clamp on the funnel. Apply vacuum as required. Wet the filter with small volume of distilled water to seal the filter against the base. Then shake the sample vigorously and quantitatively transfer required volume of sample to the filter using volumetric pipette. Carefully remove the dish filter from the base. Dry the filter paper for at least 1 hour in 100 Celsius until 105 Celsius. Then take out the filter paper and cool it in a desiccator. Make sure the sample is completely cool when weighing it. Last, we need to record all the data in laboratory sheet and calculate with the formula given. Next, we go to acidic and alkaline pH. For the procedure, first we need the sample temperature and the ambient temperature must first be brought into equilibrium. Second, pour the water sample into the beaker. pH buffer 4 to 7 are getting ready. To avoid any carryover, thoroughly rinse the probe and both electrode with distilled water, then pat dry with soft absorbent paper. For the 5, pH buffer 7 immersion probe procedure are carried out. When the electrode appears in the sample, make sure the sample depth is sufficient to cover the junction on the electrode. For the 6, the sample is gently stirred with the magnetic stirrer and stir bar or by hand after the electrode has been inserted. The pH measurement will be taken and noted. For the 8, distilled water rinse the electrode and the spot was dry with absorbent paper to remove excess air. Removing the electrode is removed and build and dry as in step 4, then pH 4 buffer and using repeated step. Then store the electrode in storage solution or shipping container until the next use. If you don't have absorbent paper, we can use a soft tissue.